Hello everyone, welcome to this session on the lab program. So this is a lab program wherein we have to clip a line using the Cohen Sutherland line clipping algorithm. So as in the theory part, I've already explained how a Cohen Sutherland line clipping algorithm works, and also we have solved many problems on this. So we'll see how we have to implement this as a part of our lab session. So first is we need to initialize the necessary header files, and then here, as we already know in the viewing part, we have a window and a viewport. So first we have to represent what is our window coordinate and what are our viewport coordinates. So that we are representing here, that is like what we call as the x-min, y-min, x-max, y-max, and this x-min, y-min is representing our window coordinate, and the uh, viewport coordinate is what we call as the projected or the scaled part of our window. So this is represented with the values for the viewport coordinates. And in the Cohen-Sutherland line clipping algorithm, we know that we have some byte codes which are being assigned. So these byte codes are assigned for our four regions basically, or that is initially we have some four white codes as left, right, bottom, top. So how do you find, or how do you assign for all these is based on whether it is to the left, based on whether the region is to the right, whether it is to the bottom, or whether it is to the top. So for that initially this is the values which we will take, and then we will decide whether the line is to the right or to the left, or where, that is to which part of the region it belongs to. So I'll show you here, that is to again remind you of that. So if this is your region, so you have a region like this. You have a region like this. You have a region like this. So these are those 9 regions which are identified. So to find that, first the initial byte codes alone we have identified here and initialized as constants here, right as 8, left as 2, top as 4, and bottom as 1. And now to decide whether that point is lying above your clip window or whether it is below the clip window, that is like this, whether it is so if you take it in this way, so whether it is lying here, whether it is lying here. So to identify which part of your region, whether it is to the right, whether it is to the left, or which part basically that point lies, you have to perform this. So first we have initialized code as 0, and if y is greater than y max, so it means that it is above your y max. So if it is greater means what, it is more than your y max line. So this is your y max. To just state here, this is your y max line. So it means that the point is greater than y max, so it means it is above the clip window. So we say that code is equal to code on top. And in the same way, if it is less than y min, so where is our y min? Y min will be somewhere here. If it is less than y min, it means that it is below the clip window. And similarly, if it is greater than x max, the same line, it means that it is to the right, and if it is less than x min, it means it is to the left. So in this way we decide what is our code, and then we are returning the code. So this is what the compute of code function is doing. And then the next function, the Cohen Sutherland function. So this Cohen Sutherland function is basically our main algorithm. So here, this is where actually the working of the algorithm happens. So first we have some basic initializations, and then we have calculated output 0 and output 1. So this is say like if I have 2 points in this way. So if I have 2 points, so I have to compute the outcode of these 2 points first. That is, if I call this as point 1, so I have to calculate the outcode which we followed the and, that is the logical and what we did. So using that, you have to calculate the outcode of this and the outcode of the two endpoints. So outcode 0 will be the region or that part of the first point, and outcode 1 will be the part of that second point. So in the Cohen-Sutherland algorithm, I told you about three conditions. First is wherein a point, both the points will be inside your region. So inside in the sense this part, that is here, that is it is here, or there may be a condition where one point that is inside, or it is a case where both the points are outside. So somewhere like this can be one such case, or it can be a other case wherein one point is inside and other point is outside. So the first two cases, so this case where both the points are inside, both of them are, it is a accepted case. Here both are outside, it is a trivially rejected. But this third case where one point is outside and one point is inside, or wherein it can also be a case where clipping can happen at both the sides. So in that case, it means that we have to calculate the intersection point. So first you check the logical and, that is what we did, that is all your when you're calculating the logical and, you have to get all as zeros. Only then you will consider that to be a candidate for clipping, and you will calculate the intersection point. So this is how we are doing the outcode out and the logical and of the top. So if this is true, this is like you are checking whether you have to find your x intersection or y intersection. So if it is intersecting with either of your top and or the bottom, you will be finding out your x intersection. Y will be the same, either y will be kept as y max or y min, based on whether it is intersecting with your top line or it is intersecting with your bottom line. And in the same way, when the line is intersecting with the right part or the left part, it means that we have to find out our y intersect. That is something what we think as like the parallel lines to your y axis. So you have to find out your y intersection. X you need not calculate, just like in the problem. X will either be kept same as x max or x min, based on whether it is intersecting with your right line or with the left line. So in this way, you will be computing your that is your outcodes. That is, here outcode is calculated, and then logical and is done, and then you will calculate your intersection points basically. So x and y are nothing but our intersection points here. And there can be a case where the outcode is equal to outcode out is equal to 0. That is, it means that that point what you are finding out, it may be inside only. So it means that one point you can just keep it as the same. You need not perform any kind of clipping on that. So you perform this till you have completed with both the points, both the end points. That is till it is done. So till this loop is completed. Once you have computed your intersection point, the next step is to display that point. So displaying means that we have to basically use our GL underscore lines, and using GL underscore line we have to draw. But here in this case, if you look at the output, what we are doing here is, see, our input what we gave was basically a small window coordinate, and when we are displaying that, we are actually giving a kind of zooming effect, or what we call as scaling here. So this smaller rectangle is our window coordinate, what I told in the beginning, and after clipping, what we are representing or we are displaying here is our viewport. So why are we doing this? Is just like a kind of a zoomed or a scaling effect we are giving here. Nothing other than that, nothing complicated here. Only we are giving that scaling factor. So that is what is being done here. So if accept, that is if that line is accepted after intersection, after finding out the intersection points, how do you display it? Is you're basically using, or you're taking a scaling factor here by subtracting your xv max and xv min and dividing. So something like you're giving an newer value of your scaling factor sx and sy, and here this is your new coordinate for your viewport, that is your vx naught, vx 1, vy naught and vy1, like what we represent as our the x max and x min in that way. And once you have found out the coordinates for your viewport, so here the viewport is larger than your window coordinate. It is not diminished scaling which is happening, it is a scaling where it is increased in size. So how do you know that? See, observe this equation, we are multiplying with our scaling factor sx. So if it is 1 by sx, it means that we have actually reduced, but it is just into sx, so it means that our object is actually increased in size. So we can call this as a increased scaling factor. So now you have your the updated viewport values. Using that, you are starting with the line loop. So here line loop is used to draw that outer rectangle kind, like what we do using our for our polygon. So we are writing GL line loop, and four that is 4 GL vertex functions are given. So what does this mean is, we are trying to draw something like a rectangle or a square. So that is what is this bigger rectangle or the square, and then within that we have to draw our clipped value. So that is what using GL lines we are drawing here. And in the same way, you are using GL line loop to display your old value of your that is before clipping, how it was looking. So even that window, that is the window coordinate you're drawing here. So, and the Cohen Sutherland function, I already told you, this is the main heart of our algorithm. So you can just do the backtracking from the main function, how it is being called. So here nothing new is here. We have used the display mode, a single buffer is used, and the coloring mode we are using is the RGB. We have set a window size as 500, 500 pixel, and here the window position is 0, 0. We have given a name to the window, my init, and display function. In display function, again nothing much. We have set the background color here to black, and then we have set the matrix mode to projection, meaning that and projection is happening, and we have set the aspect ratio here. Once it is done, we are back to the model view. So in this way we have executed this Cohen Sutherland line clipping algorithm, where this is before line clipping how it looks like, and after clipping the line, this is how. So you can try it for multiple lines. This is just one for demonstration's sake, only one line is taken. So now your doubt should not be why this is a smaller rectangle and why, or a square, and this is a bigger. We have actually scaled it, and we have displayed our clipped line within an scaled or an zoomed window or a viewport. We basically call this a window to viewport mapping. So this is our original window, this is our viewport. So this should be the expected output. So this is your before and after clipping, this is how it looks like. Thank you.